Hey everybody, Alex here, healthhacksreview.com. This is part of my scam series, little special episode here on different emitters and infrared saunas. And it's just a quick comparison. You'll see the chart below on my website. If you're seeing this on YouTube, just go to my website. You'll see the post with the actual chart laid out. But I'm just going to make a few brief commentaries on this because there are a few different companies out there. When you look at ceramics and you look at ceramic rods, alloys, and carbons, okay, you have to look at the industry on a timeline, okay? Now, most of the emitters that saunas are using were made, are made, still are, and were for other industrial applications, heating applications. Okay, it could be heating a space, a car seat. It could be drying paint. I mean, whatever it is, okay? And then a few companies will make their emitters specifically for saunas. It's very unusual, okay? But most of them are, taken from another industry. So there's actually a lot of industry data out there that you can get if a company is not going to furnish you their manufacturer specs on their emitters. Usually just visually looking at their emitters. Usually you can get them to send you a picture, or you can see it up close. And you can pretty much find, I mean, a lot of these are just standard, taken from other industries again. And you can then approach those companies that make them and basically find the different ratings, okay? The emissivity ratings, things like that. Okay, so and I just want to make this quick point. I'm looking at Clearlight's website now, one of the big sellers of infrared saunas. And I just find it interesting, people know this about me, that I prefer ceramics in general. If we just had to say, oh, we don't want to pick ceramics, we want to pick, carbons. Obviously, as you know, listening to me, it's not just the end of the story. Just pick one of them and one's better and that's it. There's a few other steps. You can't just pick it and then one's better than the other and that's it. There's other systems behind it or conditions that can affect the therapeutic experience. But if you had to pick one, yeah, for sure, most people who are really into infrared therapy, east, west, all over the place, people really know what they're doing in the real detox centers and clinics and rehabilitation places, they usually always pick ceramic. And even right here, Clearlight, I find it funny, they're basically admitting this. Raytech, one of the leading infrared instrument manufacturers, has the following emissivity tables on their website. When reading the table, please note, blah, 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 blah. Okay, you will see ceramic has an emissivity of 0.95, the closest to a perfect black body at 1.0. This is why the patented ceramic compound that we add to our TrueWave 2 heaters is so important. So basically what they're saying is, wow, ceramic is really good stuff. It's so good. We had to add it to our heaters to make them awesome, So they're all about the ceramic. But when you actually look at how much ceramic element is actually in their heaters, if they're all about it, you would think that you'd go in there and say, okay, what are your TrueWave heaters made of? You expect to see a lot of ceramic, right? It's tiny. It's a tiny percentage. 1%, 2%. I'll give them the benefit of the doubt. Let's say 5%, whatever. The point is, they're really more like a carbon fiber emitter, the company, what they produce, okay, for their saunas. But at the same time, here they are saying that, wow, ceramics so good, it's so much better than carbon, we had to add it in there. And anyway, all right, so besides that point, if we look a little bit at my chart here, where's my little chart? So I want to make a brief commentary here because if you look at all the different brands out there, you can basically figure out what generation of carbon emitter or what generation of ceramic type of element are they using. And if we look at ceramic elements, and I'll make a brief commentary now, there's a couple brands out there. I'm not going to say the brands because people get a little feisty and angry and threaten lawsuits. This is normal in this industry. But I will say that some of the first ceramic types of heating elements that were used for industrial applications were in the form of rods, okay? And they're usually cylinder rods. They look like rods. These tubes, or they're tubular ceramic heaters. There's tubular ceramic heaters, and then there's incolloy rod heaters. And actually, if you just Google those terms, as you see in the chart, you can actually find some companies that sell them, some manufacturers. And those manufacturers will happily give you their emissivity ratios, their surface temperature ratings, the micron range you would expect to see, so on and so forth. Anyway, so we talk about in-colloid rod heaters for a second. So there's a few companies that are proud of using older generation ceramic heaters. And they didn't feel like keeping up with these other ceramic companies, basically, that were graduating to full, wider, curved, like full ceramic emitters. And so some of them are concave, by the way. Those are some of the later generation ones. And that's how you can tell just visually. So these rods really are best for very specific industrial applications. For the use in the sauna, definitely not ideal. Why? Because one thing is that as far as ceramic types of elements go, their efficiency of electricity conversion to infrared is very poor, about 50%, okay? And that's about on par with some of these carbons out there. Carbons are also known to be very inefficient. And actually, that's one of the strengths of true ceramic emitters, the later generation ones that some saunas are using. They're way more efficient. And some of the best ceramic emitters are like 96% efficient versus 50%. Now, I will say that there are some other types of less efficient ceramic emitters also that aren't rods that might get up to like 70% efficiency. Just throwing that out there. Most of them, the rods for sure, the tubulars are like 50%. Definitely one of their weaknesses. They have a very high watt density, so they have to concentrate a whole lot of the wiring into a very narrow space. They have very little surface area, right? They're very, very skinny, very little surface area, then a wide panel. And so what happens when all that high watt density is going in there, when you turn on the sauna, you turn it off, doesn't matter where you set the thermostat. If you turn it on, it draws its respective amount of power it's designed to do, and it will get to a certain surface temperature with ceramics it's fast. Within like 2 minutes, it'll reach its maximum surface temperature based on its wattage rating. And because it has such that high wattage density, and it doesn't matter what they did, this company claims they did. They threw magnesium in it, they did this to it, they put it on the outside, the ceramic put it on the inside. Same high watt density usually, okay, and you can ask to see the specs. And it has a very hot surface temperature. These things get very hot. In fact, people that have done infrared therapy for a long time, traditionally, if they had tried a ceramic ones like years and years ago, a long time ago, usually it was the rods, and usually people would really feel burned on their back, like real intensity, because these things would get very hot, the surface temperature, 700 degrees plus on average. Again, high watt density. What happens when that watt density and that surface temperature gets very hot? Micron range falls, okay? And again, if you have any question, just ask them, say, where's your spec? Or try to find the manufacturer that, you know, makes that same type of rod or tubular system. And we're looking at a micron range of 3 to 6 microns at a very hot surface temperature, okay? And yes, it heats up the sauna very quickly, and they might mention that as a good perk, and that is nice. It heats it up fast, but this is about therapeutic infrared. That's what you're concerned with. That's what gives you good efficacy and the health benefits you want. So you don't want a 3 to 6 micron range. Now, if you approach some of these companies that sell older generation basic ceramic types of elements, or even carbon elements, right? But let's just stick with ceramic for now. They may fall onto the, I say, excuse or the explanation of, well, you know, the vital range is 2 to 20. 2 to 20, okay? So, you know, what is, but almost any company, most companies would agree, and it's already well known for decades of research, that while 2 to 20 does stimulate the body in some way, and you can actually receive you'll feel the energy, the infrared will actually stimulate the body in some way. Usually, like within the range of more like 7 to 10, within that range area, that's the one that really is most resonant with the tissues, like the water and the cells, okay? And that's what we're off. We want something the most stimulatory. The cells are naturally resonating to around 9.4. Everything is about resonance, and so we want to stimulate within that bandwidth itself. Okay, so yes, that full range could stimulate you in some way, but it's all about the frequency and the quality of that wavelength. So you narrow it down even further, and most companies will agree even with that. That's why in most of the marketing material they're always talking about 7 to 10 microns. The only companies that don't talk about that, guess what, are the companies that have an element that is producing between 3 to 6. Of course they're going to say, well, 2 to 20 is vital, you know, or 2 to 10. 2 to 10. They want to get it down to that 2, right? Because they know they're falling within that lower range. Okay, and we're more after the far range of things. So that's the excuse they fall back on, and I mean, I think that's been disproven enough by now. So, it's just an excuse, in my opinion, for having an old generation emitter that really is better suited for drying paint on a car or something like that. It's better suited for these other types of environments. Anyways, so I'd say if you're going to do a ceramic, at least make sure that that sauna has a concave or an actual ceramic emitter that is like, the way you'd identify it is it would be like flatter, okay? At least. That's at least a little bit of a later generation ceramic. But again, there's much more to analyze, and there's a problem with even those, ideally, if we really analyze it further. So with that, looking here real quick at the carbon elements, the main issue with these guys is that their efficiency, okay? Their emissivity is very, very low, all right? And in general, they will, in general, even if they're older generation, put out a little bit more of a longer wave. But and if a company's claiming that and they're throwing out a micron range there with that comment, just say, where's your spec? Where's your manufacturer spec? Not by the way, not the test that they did, okay? You want the manufacturer spec, some sort of like paperwork that shows the manufacturer, doesn't have their name on it anywhere. I'm even suspicious of third-party studies that were paid for by the company, right? You want the manufacturer spec, like what the factory itself, okay? The factory, the manufacturer themselves, they create the product, they're going to test it. And then that's how they sell it. They sell it then to the company. They say, well, these are our ratings, and this is what this produces, and blah, blah, blah. Would you like to buy it? And then the company imports it, puts it in their sauna. You have to get to that level, at least, to 100% know that these numbers are not fudged in some way and are accurate. And what we get is that, again, usually it's 4 to 6. A lot of times these older carbon ones are not that much more efficient getting to the far range. Still quite low. You might get, for some, 7 on the farthest range, longest wave. But the issue then is that they are so inefficient, and their emissivity is just so low that, again, as I've shared in the other video, most of those panels along the walls, above your head, on the side walls, on the front, are useless therapeutically. Useless. Okay? They're there to heat up the cabin because they're so inefficient. That cabin will hardly heat up. It might take like 2 hours, 3 hours if they didn't have them all over the place. Unlike a ceramic, right? When we look in a ceramic based sort of sauna, there's very few emitters. Yeah, it's because they're converting and putting out way more infrared. Okay, so the only part of the therapeutic panels in a carbon is right behind you, and you better make sure that you're right up against those carbon panels, because again, their actual fluence, their intensity is so poor that if you're just 8 inches away, well, let me see, 8 inches is maybe like 8 inches is maybe like that. But if you're that far away, hardly any of that infrared is actually reaching you. Unlike a ceramic emitter, not a rod, but more like a concave sort of emitter, which really beams the infrared further. Even a rod itself is going to beam, it's putting out tremendously more infrared, so it's going to definitely affect you at 8 inches. But what's more superior in its distance that it can cover, and the fluence intensity is a real ceramic emitter. Okay. And by the way, there's a difference between a ceramic emitter and a ceramic rod or ink alloy. So if there's a company that's using a ceramic tubular sort of ink alloy rod or something like that, a ceramic rod visually, and they're calling the ceramic emitter, correct them and ask them, well, what is it called? What is it called? What is it called? What is it called? And if they refuse to say ceramic, if they keep saying ceramic emitter, it's a lie. Okay, there's a difference. They're not even using the right terminology. Okay, for their own, they're trying to liken themselves. Some companies do this to a ceramic emitter. Not the same thing. Okay, so where was I? So it's important where you're positioned. Again, when you look at a carbon sauna, okay, if you're evaluating them, just remember that just that little portion around the back side of your body, just around your backside, where those panels are, that's really only going to be the therapeutic. You're only going to be getting therapeutic infrared from that small portion. Okay. That's also why, by the way, in ceramic saunas you see so few emitters in general, because they know that there's enough intensity coming off of them, and they just are going to beam it right into your body. That's more than enough. But with the carbon panel saunas, again, you see the panels everywhere because they have to heat up the whole sauna because they're very inefficient. Now, there's also an issue with what the carbon panels are actually made out of, and a lot of them in general, the way they're traditionally done, have a lot of materials that just don't belong in something that's going to heat up. Okay, again, they're for other industrial applications, and they're still using that same technology in most of them. It's a different environment when you're heating something up in an enclosed air environment for human usage. Okay, so just look at some of the materials that are used in some of the carbons to make them. Okay, and heating that up, that's where we start to get in with, and then some of them have the nerve, about 90% of the carbon companies, to glue a sort of polyester fabric on top of the heater. Bad idea, okay? And anyways, so as you know, I'm not a big advocate of carbon per se. It's fine in the car seat if you want to warm up your car seats, right? They're great for that. But in this type of an environment, I don't think they're very well suited at all. If you have to get something, I mean, those are your only options, then I'd say, yeah, it's better to have a little bit of infrared than nothing. And there's some lesser of the two evils, some that are less with the off-gassing, things like that, and I can help you figure that out if you really have to get a carbon, okay? But at the same time, if you're on a tight budget, if you're running out of options with the brands you're evaluating and none of them are that good, that's when I'll usually say, look, let's switch over to an infrared mat. Let's get an infrared pad, okay? Because those infrared mats and pads in general, none of them really have a lot of these toxicity or off-gassing issues, and they usually put off a lot of infrared, and they're right up against your body. They're very affordable. They're portable. Infrared pads and mats are great, therapeutically speaking. And a few of them put off a huge amount of negative ions, which is a whole other area of understanding what's good for the body. We can talk about another time by message or give me a call sometime. So there's another unique benefit with the pads and the mats, but a lot of times, depending on your situation, sometimes it's better just to switch over to an infrared mat versus getting a whole sauna if you just don't have good options of brands that you're working with. Okay, but that's pretty much it for now. If you have an issue or a question about some of these, this chart that I put out there on the different emitter types, elements, heating elements, ceramic elements, just let me know, and I'll be happy to share a little bit more information. And I always will evaluate any brand if you have sent it my way. And if you haven't been able to get information from the company, from the manufacturer, that would be a good time to ask me, because there's a good chance that I already got that information. But hopefully you learned a little something on my long-winded video here, and thanks for watching.